Whenever we have one function divided by another function, for example x squared minus 1 divided by x cubed minus x plus 2, we need to use the quotient rule, which states the derivative of a quotient of two functions, u over v, is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. So for this problem, we'll start with v, which is our denominator, x cubed minus x plus 2, times the derivative of our numerator. The derivative of x squared minus 1 is just 2x, minus our numerator, x squared minus 1, times the derivative of our denominator, which is 3x squared minus 1, all divided by the denominator squared. So then we'll take a look at our numerator and distribute it out and try to combine like terms. So 2x times x cubed is 2x to the fourth. Negative x times 2x is minus 2x squared, and plus 2 times 2x is plus 4x, minus, and then we'll distribute out the other two terms, the other two binomials in the numerator. X squared times 3x squared is 3x to the fourth. X squared times negative 1 is negative x squared, and negative 1 times 3x squared is another negative 3x squared, so that's a total of negative 4x squared. And negative 1 times negative 1 gives us plus 1. Still all over the denominator squared. Now we'll take our minus sign here and distribute it into all of the pieces of the second part of our numerator, and we'll combine like terms. So we have 2x to the fourth minus 3x to the fourth, so that'll be negative x to the fourth. We have a negative 2x squared minus a negative 4x squared, so that'll be plus 2x squared. We have a plus 4x, and we have a minus 1, and still all over our denominator squared. In the next problem, we've got the same situation. We've got one function, sine x, divided by another function, x squared minus 2. So we'll start with the denominator, x squared minus 2, times the derivative of the numerator, which is the derivative of sine x is cosine x, minus, and then we'll take the numerator, sine x, and we will multiply it by the derivative of the denominator, which is 2x. And we'll put it all over x squared minus 2 squared. No common terms in the numerator to factor out, and there's no reason to distribute the cosine x into the x squared minus 2, so this will be our answer. For the last one we've got here, we've got x cubed over sine x times cosine x. So we have, again, one function, x cubed, divided by another function, sine x cosine x. So as we go through here, we'll start with the denominator, sine x cosine x, times the derivative of x cubed, which is 3x squared, minus the numerator, x cubed, times the derivative of sine x cosine x, all divided by sine x cosine x squared, which I can just write as sine squared x cosine squared x. Now we need to find the derivative of sine x times cosine x. So in order to find that derivative, since that is one function multiplied by another function, we'll use the product rule. So the product rule states that the derivative of a function times another is the first function, sine x, times the derivative of the second, so the derivative of cosine is negative sine x, plus the second function, cosine x, times the derivative of the first function. The derivative of sine x is cosine x. If you're unsure about the product rule, there's another video up for the product rule. This simplifies down to cosine squared x minus sine squared x. And using a trig identity, that's equal to cosine of 2x. So where we're at now is 3x squared sine x cosine x minus x cubed cosine 2x all over sine squared x cosine squared x. If we want to, we can factor out the x squared from the numerator, but that's the only common term. We can get x squared times 3 sine x cosine x minus x cosine 2x all over sine squared x cosine squared x. And that's our final answer.